Okay, so I realized maybe at some point I tried to explain something, but I was not able to explain it very well. So here, um, here is a band structure that you would get from, say, COMSOL maybe. Um, the horizontal axis is the wave number, and the wave number, if it's smaller, then your wavelength is longer. If it's larger, your wavelength is shorter. So close to the origin, your waves have a very long wavelength. So that's the interpretation of what the wave number is. Frequency is frequency. That's fine. Okay, so consider an let's say that this band structure was produced by this array of dielectric spheres. Bloch's theorem, which is right here, says that your electric field will be a product of a periodic function with a plane wave. So e to the ikx. So the reason that your band structure is periodic, the things that you see here will be repeated every 2 pi over a. The reason for that is the following. So let's say that you start out, so you know what your u of x is. Say COMSOL told you what it is, and you know what you've solved for that particular k. Actually, in COMSOL, you would just put this in as a boundary condition. It's the flow k boundary condition. So what you can also do is you can say this will now be the same u of x, the same periodic function, times e to the I k minus 2 pi over a x times 2 pi over a x, 2 pi I over a x, I guess. Right. And you can rewrite this now as u of x. I just put everything in a different order. Copy, paste, and do this. Right. And you may have noticed that this thing here is periodic in A. Let me make that explicit. A is the lattice constant of our array of dielectric spheres. So A is, so this part of the function is periodic in A, which means that this whole thing is also periodic in A. So this becomes another type, or another, another in quotation, another solution that you can write down for your Maxwell's equations. So another choice of u and another choice of k. But it's the same solution, so it must have the same frequency. And what this new k vector is say this was the original one, then the new k vector is just here. Or k is down there, but yeah. And they have the same frequency. So those 2 points describe the same state, the same solution that was returned by whatever software you use to calculate the eigenfrequency.